How's it going, guys? Welcome to my video tutorial on how to use TypeScript. We're going to be starting with very simple introduction to TypeScript. But before we get into TypeScript, we're going to do some JavaScript code. So when do we want to use TypeScript? What is the purpose of this? Why is it important? Well, if we take a look at JavaScript, let's build a regular function. I am assuming that if you're looking at this video, you already have some basic understanding of JavaScript. So we're just going to create a function. And this is just going to say, let's just say return item. So return item. And it's just going to take in whatever this item is. We don't know if it's a string or a number. So whatever that item is, and we're just going to return it. In terms of functionality, this thing doesn't really do anything. It's a terrible function. But we can just use that for an example. And now if I console.log this, and I invoke it, return item, and we pass in, say, like a string. So I'm going to pass in hello. Let's go ahead and give this a run. So I'm going to run node test.js, and we can see that hello. And if I give this a run, but instead of using hello, I change this to be a 1, we're going to get hello, and then we're going to get a number. So we can see this type of item is changing. And you can hover over item, and you're actually going to see that the type is of any. We're going to learn any and when we get further into TypeScript. But for now, we have these different types, and this can introduce a lot of problems. Specifically, TypeScript is made for developers, so we can kind of catch our bugs early before we actually have to compile it. So let's see one of those errors. What if instead of return item, this is maybe slice item, right? So now slice is a method, and slice is a method that works on strings. So slice is a string method. And if I try to slice this, what we can do is I can do item.slice, and let's just say we want a copy of it. So I'll just slice from the beginning. It should still print out hello. It's going to print out a copy of hello. Let's go ahead and run that now and see what we get. Cool, we're going to get an error, right? So it's saying right here, actually, this is a different error. Give me 1 second. That was my bad. We changed the name of this function, but we didn't change it over here. Okay, so there we go. Now we get an error. So what are we getting? We're getting undefined here, just because I'm not returning anything. But it looks like the code worked perfectly fine. But if you see here, item.slice is not a function when I run this code. Let me just return this so that we can actually get that output. So here's that hello. We're getting that as intended, but items.slice is not a function on this one. I could probably change it to a string, and now it works perfectly fine. We can use slice on that because it's a string. But you can see how this type could create an error. So in JavaScript, if we want to protect against that, maybe we have to do something like if type of item is equal to string, then we can use slice. Otherwise, it could be anything else. Then we'll just say return the item, something like that, right? So now this works perfectly fine. Again, this is a sliced version of the string, but we're only running this command whenever the item is a string. So this is kind of annoying, and you can see it can cause some issues, right? The more types that are introduced, the more ifs we have to write, the more checks we have to do. And also, there's no way for me to know that this might bug. If I return this back to the way we had it before, so if I just set this back to return item.slice, as a developer, this looks like it's going to work, but I don't know it's going to work until I actually run it. So once I'm compiling my my JavaScript using Node, then I finally see that error. And you can see it worked once, but it didn't work the other time. And this error is very vague. It just says it's a type error. Item.slice is not a function. Doesn't really tell me much. So what if we did this in TypeScript? TypeScript would take care of that for us, and I would not have to run node to see that error. I would get it right off the bat. So let's do that. I'm going to head on over to our index.ts, and we're going to build that same exact function. First, I want to point out that JavaScript and TypeScript are basically the same thing, but TypeScript is a superset of JavaScript. So what I mean is if we have JavaScript exists right here. and this is everything that you know for JavaScript. TypeScript is a superset, and it exists over here. And this is TypeScript world. So it can do everything that JavaScript can do, but it can also do everything that TypeScript can do up here, which is usually type checking and things like that, right? We have superpowers. Think about it like you can play the game. The game is JavaScript, but we want to add mods. These are the mods. It lets us do a lot of really cool things. So with that, I also want to point out that TypeScript is going to transfile. So it's going to spile, I believe is the word, is going to transpile, which means it's going to change from TS to JavaScript. Let me make this yellow really quick. So it's going to change from TypeScript to JavaScript. Then what we can do is we can run node on JavaScript to get our output. Then that's where we do the compile. So that part, if it was a little confusing, I'll cover a little bit more about that in the readings, but that's just the basics of it. So what I mean by that, let's take a look. If I just do console.log hello, this is just basic JavaScript. And now I need to output this. Or before I output it, I can actually just run index.ts because this is just JavaScript. If I take all of this code that we ran before, I'm going to need a test really quick. So if I take all this code we ran before and I give this a run, this also works. So we're getting a hello because it's just a copy again, but this is just JavaScript. But now let's go ahead and add some flavors to this. We're going to add TypeScript to it. So the original issue that we ran is this slice item is taking any, and that could be anything. It could be a string, it could be a number, but this specifically is a slice method that only works on strings. So if I'm building a function and I want other developers to know that this has to be some sort of string that you pass in, I can specify that. So the way we do that is in the parameters, here's a variable that we created. I can put a colon, and then I can specify a type. So let's here specify it's going to be a string. Now I can run my code, but if I try to run this with Node, you're going to see this is now TypeScript. And we're going to get this big old error down here. It has no idea what this is. So what do we have to do? We have to convert this TypeScript into JavaScript. So what we can do is if we go back down to the terminal, there's a command that we run on our TypeScript files called TypeScript compiler. So we use TSC, again, stands for TypeScript compiler. Then the name of our TypeScript folder, and you can see it's going to output this index.js file, which is basically just JavaScript code. And it actually looks almost exactly like this. So perfect. Now I can run Node on that index.js file, and it works perfectly fine. So why did I have to do all these extra steps? Let's take a look at it. What if I try to do my slice item with the number 1? You can see I'm getting a squiggly. It's already telling me before I even run anything that I have an error. If I hover over it, it says this is a number, and it's not assignable because it needs to be a string. This parameter needs to be a string. So it's letting me know I could do this with a whole bunch of different things. Even if I did like an array that has strings in it, slice doesn't work on an array, so I'm already letting them know that this is going to cause an issue. So really cool from a developer's point of view. We can stop a lot of bugs and we can speed the debugging process up. And look at that. It already tells you the errors before having to run anything. So pretty useful. And that's kind of where we're going to be heading towards it. So before we get into that, let's also cover some of these types. So let's look at the different types of types. Very wordy thing I just said. But when we're declaring a variable, so in JavaScript, we can just say like let item is equal to, I don't know, or let's make this let string is equal to a string that says hello world. So we can just do this in JavaScript and that works perfectly fine. You can do this in TypeScript as well. But if we wanted to be strict about what type this is, we can type in here string. And now this is a type of string, right? If I hover over it, it's going to say a type of string. Keep in mind, this is not string with a capital S. This refers to the class string that exists in JavaScript. This refers to the type of string. So let's do let num. That's going to be set to number, which is going to be like 1. We can do let, let's say bool, which is going to be set to a Boolean, and that's going to be true. We could do undefined. We could do that. Let we'll just say that, I guess. Undefined is equal to, it has to be undefined. We can even use null. So we can say like, I guess we'll call it nothing. Nothing, which is going to be type null, and that's going to be set to null. We can also do arrays if you wanted to, and I'm not going to get too much into arrays, but we can say something like let array. Arrays, we use these empty square brackets to declare an array. So that's how we can create these variables, these types. So let's take a look at that. I used let, which in JavaScript would mean I can reassign it. So what if I do string, string is now equal to hi? That works. What if I try to change this to be a number? It's telling me that I have an error because string has to be a string. I can't reassign it down the line. So very useful. What if I want to change bool to be equal to false? That works. It's a Boolean. Can I change it to be false? No, that causes an issue. Already, you can kind of start seeing where we're going. This is extremely helpful, and it's doing the debugging for me without having to run node to figure it out myself. Pretty cool. These are all the different types that we have. Going back to our function, we can also take this a step further. So what if we're doing some sort of function? Actually, let's do a new function. What if we want to build a function, and then this function is going to take in a string, but it's going to output that as an array, right? So build a function that takes in a string, but outputs an array. So maybe like, I don't know, build a function that we're going to use like split or something. So what we're going to do is we're going to say, here's our function. And our function is going to say, I don't know, split string. And this is going to take in some sort of variable, which we know is a string. So I'm going to say string. And what we're going to do is we're going to specify this argument or this parameter right here. And we're going to say that this is going to be string. But right here, after the parentheses, I can specify a return type. So if I put here, I'm returning some sort of array, you're already seeing I'm getting a squiggly because I don't have any type of return. So if I do return string, that gives me an error right off the bat. It says it needs to be returning an array. If I say return an empty array, that satisfies this condition. But I'm not running anything with the string. So let's go ahead and do that. So what if I say return string dot split at every single thing, something like that. So it's not assignable. So this is because it's a string. So maybe this isn't a good example with split, but what I can do is just say let res is equal to this. And maybe I can say return res. Yeah, this is just an anything. Yeah, I guess this isn't a good example. But what I'm just gonna do is we can showcase with arrays. We can say this is going to be a string array. So that means this array can only hold strings. So for example, this doesn't work. I can't say return this because that's not a string, but I can say this and that works. I have no more errors. So it's an array that only holds strings. So now I can go back to do my string dot split. And this works perfectly fine. So now I have no more errors. So if we call this split string function and I pass in a string, you can see right here, it's even telling me I pass in a string and it's going to give me a string array outputted. So that works perfectly fine. Or I could say split string and pass in 1 and it gives me an error. What if I try to pass in an array that's already a string? Perfect, it's already protecting because split wouldn't even work on this, right? So pretty cool. That's just an introduction to TypeScript. And we'll just recap everything we covered. We can declare parameters as types. We can declare return types as return types with types. We can check the errors before we actually have to try to before compile. And these are how we declare different types. And TypeScript is going to be checking things. The way we convert this into Node is we use TSC, which is TypeScript compiler, the name of our file, so index.ts. Let's take a look at this really quick. I already have this function, this file is already created for me, but it's not updated. So if I run this TSC command on the TypeScript version, it's gonna update it. And it's kind of ugly. Some of this stuff is pretty ugly. Like, I don't really want to use var, but TypeScript's pretty smart to use var where it needs to use it. But again, some of this stuff is pretty outdated. So yeah, we covered some pretty cool things, and that's basically the introduction to TypeScript. So hopefully this is helpful for you guys, and I'll catch you guys next time in the next video.